Okay, hello dear students. This class is the continuation of this chapter lens, okay, which you were taught earlier. In that class, you were taught about the types of lens, okay, definition of lens, type of lens, difference between concave and convex lens, lens formula, okay, magnification formula, power, everything was taught in that class. Today's class, let's do the ray diagrams, okay, for lens. Before doing the ray diagrams, you should understand some of the terms which are there in a lens. Okay, so number one, center of curvature. curvature, curvature of a lens. Okay, so if you consider a concave lens, convex lens, this is a convex lens and this is your concave lens. Now, these two lenses are made by cutting sphere. Okay, so these two lenses are part of spheres. So this section is a part of sphere. This one. And this part is from another sphere of same size. Okay. This. Oh, this sphere will have a center. Circle has a center, isn't it? And similarly, sphere has a center. Okay, that center I'll mark it here. This is the center of this sphere. This is the center of this sphere. These two centers are known as center of curvature of a lens. Okay, this is denoted by C1, capital C1, and this is denoted C2. For this, if you complete this sphere, this one, okay, these two spheres will be of same size. Okay, this and this, the center C1 will be this side and C2 will be this side. For this, C1 will be this side. Okay, for convex, C1 will be on left hand side. For concave, C1 will be on the right hand side. Okay, so these two centers are known as center of curvature of the lens. So definition, you can write: center of curvature of a lens is the center of sphere out of which the lens is made. Okay, so a lens has two center of curvatures. It is denoted by capital C1 and capital C2. So up to that you write it. Okay, so next is radius of curvature. Number 2 is radius, radius, radius of curvature of a lens. Radius of curvature means the radius of sphere out of which the lens is made. Okay, that means here to here is the radius of curvature, here to here, or from this to this one. Okay, so that is radius of curvature. You draw the write down the question and draw the picture also. Okay, after writing the definition. Next is principal axis. Number 3 is principal, principal axis, axis of a lens. It is the straight line joining the two centers of curvature of a lens. Okay, so I'm making convex lens. This is the sphere. This side there was C1 and this side there was C2. So if you join these two centers with a straight line, then this straight line C1 C2 is said as principal axis of this convex lens. Okay, so principal axis of a lens is the straight line which joins the two center of curvatures of that lens. Okay. Next is optical center. Number 4 is optical center. OPTICL. OPTICL. Optical center. CNTRE. It is denoted by capital O. Okay, so this is your convex lens. This side, this is your concave lens. This is the principal axis. For this is the principal axis. Okay, convex lens. This side is concave lens. Optical center of a lens is a point on this line. This line means principal axis. Okay, so optical center of a lens is a point on the principal axis of that lens such that ray of light passes undeviated through that point. Okay, so it is a point on the principal axis of this lens. Okay, so that a ray of light, if it comes, strikes at this point, if it is incident at this point, it passes undeviated. Undeviated means without any deviation. It goes straight, this like this. It goes without any deviation. So it is a point on the principal axis of the lens such that a ray of light passes undeviated through that point. Okay, that point is known as optical center. For this, it will be here only. Okay, so that a ray of light striking at that point passes without any deviation. It goes without any deviation. You keep scale and draw a straight line. Okay, so four topics are done. Okay, next is we have first focal point, second focal point. Okay, number 5. First focal, FOCL, focal point of convex, CONVEX, convex lens. It is denoted by capital F1. Okay, so this is the principal axis. This is your optical center O. Okay, so first focal point of a convex lens is a point on the principal axis of a lens. Okay, it is a point, this is F1. It is a point on the principal axis of the convex lens such that a ray of light coming through that point, like this. This is very important. This arrow is very important. Okay, it shows the direction of a ray from which side, from where the light is coming, and it is going in which direction. So for this light chapter, this ray is very important. This arrow is very important. Okay, so don't forget to make that. So I was talking about the definition of a first focal point of convex lens. So it is a point on the principal axis of the convex lens such that a ray of light coming through that point after refraction becomes parallel to the principal axis. That means from here refraction takes place. Once it gets refracted, it becomes parallel. Parallel when I go like this. So it is a point on the principal axis of the lens, okay, such that a ray of light coming through that point after refraction becomes parallel to the principal axis. So this is the definition for first focal point of convex lens. Okay, number 6, opposite of this, second focal, FOCL, focal point of concave, convex, CONVEX, convex lens. It is denoted by F2, capital F2. Okay, so let me draw the picture. This is your lens. This is the principal axis. F2 will be here, this side. Okay, so F2 or the second focal point of convex lens is a point on the principal axis of that lens, okay, such that a ray of light coming parallel to the principal axis. Suppose if a ray of light comes parallel like this, if it comes parallel to the principal axis, after refraction passes through that point. Through that point means through this point, okay. Right. See, I'm again repeating this one. First focal point of convex lens is, it is a point on principal axis of the lens such that of convex lens, okay, such that a ray of light coming through that point after refraction becomes parallel to the principal axis of convex lens. Next is second focal point of convex lens, F2 means it is a point on the principal axis of the lens such that ray of light coming parallel to the principal axis after refraction through convex lens becomes a passes through that point. Okay, so this is the definition for first focal point and second focal point of convex lens. Number 6. Number 7, same thing you do it for concave, C-O-N-C-A-V-E, concave lens, C-O-N-C-A-V-E, concave lens, F1, okay. Second for, okay, concave lens, C-O-N-C-A-V-E, concave lens, L-E-N-S, lens, F2. Okay, let me erase this drawing. And definition will be quite similar, okay. So let me make the concave lens, concave lens. This is the principal axis and here is the optical center. Here is the optical center. Oh, this center is called optical center, okay. So first focal point of concave lens is a point on the principal axis of the lens. This is F1, okay. For convex lens, F1 was this side, on left hand side. For concave lens, F1 will be on right hand side, okay. Remember that one. It is a point on the principal axis of the lens such that a ray of light appearing to come from that point, okay. A ray of light which appears to come from that point. That means यहाँबाट appear गरेको, okay. You make dot 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 dot, you keep scale from here. So you keep scale and draw a straight line. This keep scale F1, draw straight up to this straight line, okay, from your dotted line. So it is a point on the principal axis of the lens, a concave lens, such that a ray of light appearing or which appears to come from that point after refraction becomes parallel to the lens, like this. Okay, so you can say यहाँबाट आएको light हैन, light ray is not coming from this point. It is appearing to come from this point. यहाँबाट आउँदैछ light, तर देख्दाखेरि चाहिँ कहाँबाट आएको जस्तो देख्छ. यो if you extend this one, यहाँबाट आएको जस्तो देख्छ, okay. So don't forget the word appearing, okay. So it is a point on the principal axis of concave lens such that a ray of light which appears to come from that point after refraction becomes parallel to the lens, okay. So remember that word, के अरे त्यो, appearing or appears, okay. Next यसको लागि पनि गरौँ. So इसको F2, second focal point, F2 will be here. So it is a point, second focal point of concave lens is a point on the principal axis of the lens such that a ray of light coming parallel to the principal axis. Ray of light is coming parallel to the principal axis, appears to diverge through that point. Okay, here appears to diverge through that point. Divergence, concave lens is diverging lens. Okay, so light चाहिँ के हुन्छ, diverge हुन्छ. Through which point? This point. यहाँबाट यो diverge हुन्छ. स्केल राख्नु, यहाँबाट सिधा यसकै लाइनमा यो diverged like this. Okay, so F2, second focal point of concave lens. There is a point on the principal axis of the concave lens such that a ray of light coming parallel to the principal axis after refraction through the lens appears to diverge through that point. Okay, so this is the definition for second focal point of concave lens. Next is focal length. Okay, it is the distance between first focus and optical center of the lens. Focal length, it is denoted by small f. Okay, FOCL, focal length, small f, it is denoted by small. So this is the distance between focus and the optical center of a lens. Okay, it is denoted by small f. Okay, now total 8 points we have done. Okay, next is important rays. So write down the question. State the important rays that are necessary for drawing ray diagrams in case of a lens. Okay, so answer, write down 3 important rays are used for drawing ray diagrams for a lens, and they are: number 1, ray of light incident at the optical center. Okay, so ray passes without deviation. Without deviation, DEVIATION, without any deviation. Okay, ray passes without, you can add any deviation. That means this is your lens, convex, this side is concave. This is the optical center, this is the optical center. Okay, so a ray of light incident at the optical center. If ray of light is incident at this point, it passes without any deviation. You use scale, okay, for drawing this one. For this also it passes without any deviation. So this is the first ray that is used for drawing a ray diagram in case of lens. Okay, number 2, coming parallel to the ray of light coming parallel to the principal axis, PRINCIPAL, principal axis. After refraction it converges or diverges. focus. It converges towards the focus or diverges through the focus. Okay. Ray of light coming parallel to the principal axis. That means it is like this. This is the principal axis. Okay. This is for concave. Okay. Principal axis. This is optical center. Concave, and this is convex. So this side will be f1, length will be same. Okay, and same length this side there will be f. So for this side will be f2 and this side will be f1. You have to take same distance. So you can take 2 centimeter. Use optical center to f1, 2 centimeter, optical center to f2, rather 2 centimeter. Okay. So ray of light coming parallel to the principal axis like this. If a ray of light comes parallel, so this ray should strike till this center. Okay, this line, not here and not here also. Okay, this middle line it should strike. So after refraction, it passes through the focus. This one f2, like this. So after refraction, it converges through the focus in case of convex lens. Okay, and in case of concave lens, if a ray of light comes parallel, it diverges through the focus. To this point, it will diverge out. So I have written this statement, the same sentence. Okay, after refraction, it converges or diverges through the focus. In case of convex lens, it converges towards the focus, and in case of concave lens, it diverges through the focus. Okay. Next, third is a ray of light coming through the focus. A ray of light coming through the focus. Number 3. Coming through, THROUGH, through the focus. Through the focus means f1, through f1. After AFTER, after refraction, it becomes parallel to the principal axis of the lens. Axis of the lens. Okay. So in case of this is convex lens, this side is concave lens. This is convex. Principal axis, this is the principal axis. Optical center. Optical center. F1. This side is F2. This side F2. This side F1. Okay, so ray of light coming through the focus means coming through this point. Through f1, first focus. Okay, after refraction it becomes parallel to the principal axis of the lens. It becomes parallel like this. It should be parallel. This and this line should be parallel. Okay, and for this it appears to come from this point. It appears dotted line straight like this. This should be a straight line. Okay, mirror straight back. Use scale. Scale draw straight. Complete line, dotted line. Okay. So after refraction, it becomes parallel like this. These two lines will be parallel. Okay. So these 3 important ways are used for drawing ray diagrams in case of lens. Okay. So first one, ray of light striking or passing through the optical center. It passes without any deviation. In case for both the lens. Okay. Number 2, ray of light coming parallel to the principal axis. After refraction, in case of convex lens, it passes through the focus f2, and in case of concave lens, it diverges through the focus f2. Okay. Third magic is a ray of light coming through the focus f1. So after refraction, it becomes parallel to the lens. Okay, 3 important ways. I would say theory portions. Okay, now ray diagrams ones. Okay, next heading you write it. Image formation. AGRA. Formation of image by convex lens. Okay, so first you got a ray diagram for the formation of image by convex lens. Okay, so for this you have 6 different cases. Case number 1, when the object is at infinity, infinity, infinity. Object can say infinity because infinity means extremely far distance. Okay, where will be the image formed? Number 2 when the object is beyond 2f1. 2f1 देखि अलिकति बाहिर हुँदाखेरि 2f1 भनेको के हो I'll explain you later. Okay, so 2f1 भनेको त यो हो खासमा. It is like this. यो भयो यहाँ f1 हुन्छ. This is O, this is 2f1. Suppose if you take here to here 2 cm, यहाँदेखि यहाँसम्म अर्को 2 cm लिनुस्. Okay, if you take here to here 3 cm, this to this will be another 3 cm. So this is 2f1. Okay, यहाँदेखि outside भनेको beyond this, यहाँ object राख्दाखेरि कस्तो खालको image बनिन्छ. Okay, next number 3, when the object is at 2f1. यहाँनिर object राख्दाखेरि 2f1 मा object राख्दाखेरि where will be the image formed and how will be the image formed? What will be the characteristics of the image formed? Real हुन्छ कि virtual हुन्छ कि magnified हुन्छ कि okay diminished हुन्छ कि त्यो गर्नुपर्छ. 3, 4 मा चाहिँ when the object is between BW, B/W means between 2f1 and f2. F1, 2f1 and f1. यो दुईटाको बीचमा यहाँ र यहाँ object if you keep here, where will be the image formed and how will the image look like? Okay, whether it is real, inverted, के छ त्यो criteria we have to do. For number 5 मा when the object is at f1 यहाँनिर राख्दाखेरि f1 मा राख्दाखेरि okay this place. Next 5 भयो. Number 6 मा when the object is between B/W means between, okay, between f1 and O. यो f1 र O को बीचमा राख्दाखेरि कस्तो खालको इमेज बनिन्छ? f1 means first focus and O means optical center. Okay, so you take a note of this one also. यहाँनिर साइडमा सानो नक्सा पनि बनाइराख्नु ल कन्केभ कन्भेक्स को लागि. यो भयो f1 यहाँनिर. This is 2f1. Take 2 cm. Okay, here to here 2 cm and here to here 2 cm. Okay, so first मा के रे when the object is at infinity. Infinity भनेको very very far distance. Okay, त्यहाँ राख्दा. Next is the object is beyond 2f1, outside 2f1. 2f1 देखि अलिकति बाहिर यहाँनिर राख्दा. Here, if you keep the object here. This is case 2. Okay, case 3 is when the object is at this place 3. यो भयो at 2f1. Case 4 is when the object is between 2f1 and f2. f1 यहाँ बीचमा राख्दाखेरि. This is 4. Number 5 is when the object is at f1 यो ठाउँमा राख्दाखेरि. Okay, and ultimately 6th case is when the object is at this. This is 5 and number 6 is this. Okay, so you make this one properly. Okay, you note down this properly. I'll continue the remaining portion in next class. Okay. Thank you.